Hello, everyone, and welcome to today's webinar, Services Engineering, from One-Off Projects to Repeatable Delivery, brought to you by TSIA and sponsored by Beacon.li. I would now like to introduce our speakers for today. Bo DiMuccio, Distinguished Vice President, Professional Services Research for TSIA, and Rakesh Vaddadi, CEO and co-founder of Beacon.li. As with all of our TSIA webinars, we do have a lot of exciting content to cover in the next 45 minutes, so let's jump right in and get started. Bo, over to you.
Well, thanks, Vanessa. Hello, everybody. Welcome, Rakesh. I really look forward to this conversation. I'm excited to hear what you have to share and to interact with our audience as well. So as Vanessa said, let's just jump right in. And let me start with the big picture. So for decades, PS has run on basically one model. You put smart, experienced people in front of a customer and then just basically let them figure it out. That is what we call PS 1.0. It's consultant driven, projects are typically custom, and then the only way to grow was to hire more people and bill more hours. And that worked really well. In fact, it worked for decades until AI economics arrived. And some of the processes and dynamics here are pretty simple. When an AI agent can do the work of 5, 10, 20, 100 engineers at near zero marginal cost, what happens to billing by the hour or the seat? It becomes a liability. So that is, in our view, what is pushing the whole industry towards what we call PS 2.0. This is the future of professional services. This is what I have spent the last 18 months documenting and researching and studying. This is delivery that is engineered and productized, priced on the outcome the customer actually gets rather than the effort that we put in. We're decoupling effort and value and price. What's the bridge between these two worlds? It's services engineering, and that's why we're partnering here with Beacon.li today. The reason is simple. You cannot automate a snowflake. So if every project is custom, if you think about it, AI has nothing repeatable to accelerate. So before we can talk about AI, we got to talk about engineering the work itself, which is exactly where I'm going to go with this next slide here. So here's the way I'd put it. Once you accept that delivery has to be engineered, the how comes down to, I would say, two principles. And the first is really a mindset shift. And this mindset says that we engineer delivery itself, not the projects. We think you have to stop treating every engagement as a blank sheet of paper. Instead, treat the delivery like a product that has a life cycle that you design and build and test and deploy and improve over time. That's the first principle, which is a mindset shift. The second is this 80-20 rule that we've all heard about, but here's what I mean in this context. And that's what you see across the top there. In almost any service, roughly 80% of what you do is repeatable, or it should be repeatable. It's the same steps, probably the same configurations, same migrations. That 80% should run on pre-built IP templates, standardized scripts, those kinds of things. It's the remaining 20% where the real customer difference lives. And that is where you preserve flexibility, human judgment, the human in the room, human in the loop. And here's why this matters so much for what comes next. The productized 80% is the part that AI is really well suited to accelerate because it is consistent enough to learn from. And I would put it this way. You can't point AI at chaos. Well, okay, you can point AI at chaos, but it's much better to point AI at something structured. So engineering the repeatable work is the precondition for everything that I'm about to talk about, and I think everything that Rakesh is going to talk about. I will admit, though, that this raises a question, which is, once we've engineered the repeatable work, how do we execute it at scale? Great question. And so this is really where AI enters the picture. And it's not one thing, it's progression across, I would say, 3 levels that you see here today on this slide. Level 1 is where we have co-pilots. This is probably where most organizations are today. It's not a bad thing, it just happens to be the fact. Generative tools sit next to a consultant. They help those consultants draft code, summarize faster, document engagements faster. And this is great, it's useful, but the human is still doing primarily the work. And this is where level 2 comes in, it's the agents. And this is really the part that I think a lot of people either miss or they're just simply mystified by it or feel like it's too complex to actually adopt. But here is really the next phase of development. It's where agents do not just assist, they actually are learning. And they are harvesting what happens during delivery, and they codify it into reusable IP so that every project you run makes the next one smarter. And that's the engine that turns your engineered 80% into an asset that compounds and makes AI economics actually work. Now, level 3 is what we call AI orchestration. Here, AI is not recommending, it is executing. It runs multi-step delivery workflows end-to-end against the playbooks that you engineered. So really what's happening here is your best people are what they do is they stop being doers and they become orchestrators of the work. And if you really notice the through line there, this is important. It's assistance, then learning, then execution. As you climb that stack, the engineered 80% gets handed to the machine, and then your humans move up to the judgment and the outcomes, the things that we're supposed to be doing, the things that make us as humans in the loop indispensable. So that brings us to the next question. What does AI execution actually look like inside a real implementation? And this is precisely what Rakesh is going to cover. And Rakesh, I'm really excited to hear about it. So over to you.
Thanks, Bo. Thanks for the context and the handover. Let me take it up from here. Hello, everyone. I would like to double click on what this AI services engineering would look like. And I come from engineering background, scaling the tech systems across multi-million user base across the company. So I think I'm fairly poised to be able to speak to the depth of it. Let me first continue the handover that Bo has given, especially the level 1, level 2, level 3 explanation of how the AI can impact the PS engineering across. So the reason why we believe that it's high time for level 3 is that we believe the current implementation lifecycle is fragmented across from requirement gathering to solutioning to configuration, testing, and go lives. And these context gaps across these phases are the ones that are actually causing a lot of implementation gaps and customer dissatisfaction when the results are out. And this is the exact problem that the AI orchestration layers could help in solving. And this is how the AI execution would unify the entire delivery experience by stitching all the lifecycle stages of implementation together and reducing the context loss between one stage to another. By doing this, it helps in higher quality implementations, more standardized implementations, and less repetitive manual work, giving more room for strategic execution by the subject matter experts or the implementation experts in this case, and also helps the newer implementation experts to ramp up much quicker because now the system itself is guiding the implementation experts with all the knowledge combined from the previous subject matter experts that are already in the system and carrying it forward for the newer folks as well. So institutionalizing this knowledge as in the level 2 that Bo was talking about, and then executing on top of it as an end-to-end orchestration layer is the level 3 that we are going to see in a few minutes. So this is how we believe that AI orchestration could help in closing out the fragmented delivery into a unified execution experience. For long enough now, the PS teams have been using point tools to solve for independent stages, and none of these tools talk to each other. Whereas with the AI orchestration layer, it could connect these tools and make some of them redundant as well as part of the process, but most importantly, unifies the entire execution and the delivery experience across projects. Now, let me take you through what I mean by an AI orchestration layer on the current implementation life cycles. So this is the current implementation life cycle that I kind of envision, which is the one that is starting all the way from pre-sales and ending at all the way till hypercare. Most of the times, PS organizations are built between pre-sales and hypercare. The reason why we include pre-sales and hypercare also as part of this life cycle is the context loss could happen even from pre-sales to requirement gathering, because pre-sales would be promising something to the client which may not have been fully updated in the scope of work documents, and that context loss is going to carry forward for the entire project. And similarly, when the project has gone live and but not enough context has been passed over to the hypercare team, they suffer with the sudden surge of support volume to take care in the hypercare. So that's the reason we believe that the implementation lifecycle is end-to-end covered only when you cover it along with pre-sales and hypercare as well. It could be different teams doing it internally in the organization, but it's important to connect the context all the throughout is what we believe. And how do we look at the orchestration that is connecting all these life cycle phases together would be to start with pre-sales, where the AI orchestration layer can connect to your existing tools that you might be using in pre-sales, like Gong or Zoom note takers or Salesforce or HubSpot CRMs, or even the raw RFPs that the client submits to your teams. And this would go in as an input. And the essence to all of this is a strong foundation of a living knowledge graph. And we'll discuss more about the knowledge graph in the upcoming slides, but that's going to be a key input along with the project level context that is coming from the Gongs and Salesforces of the world. That's given as an input. And then the output for that would be a scope of work document. And this scope of work document now can be generated as early as today. You have gone to the client and the pre-sales discussions have happened and you have done a pre-sales workshop, and tomorrow the scope of work document could be generated and can be vetted with the client directly. And you can even go an extra length and be able to connect this scope of work to your CLM tools like Ironclad or any of the other CLM tools that you can use, so that there is no context loss even at the procurement stage. And then that gets in as an input for your post-sales for the implementation team as a requirement gathering sessions. In the requirement gathering and the solutioning sessions, this scope of work will be one of the input sources. And on top of that, any other artifacts like the client SOPs or the ongoing intake sessions, you would be doing kickoff sessions with the client once the contract has signed. So all of these kickoff sessions in person, online, would become the input source for this requirement gathering and solutioning sessions. And then the output for this would be a detailed business requirement document. And this business requirement document is not something as a note taker summary. It's a detailed product level translation of what needs to be configured in the system as per the client's requirement. So this is what your best of your consultants are trying to do today. And this is what exactly the AI orchestration layer can expedite, still keeping the same consultants in the loop for the strategic inputs as needed. So this is how we connect the pre-sales to post-sales, and the end output would be a detailed business requirement document. So it would be something like, if I'm saying, okay, I would like to have the leave policies set up for these set of business units in my company, then the business requirement document would say something like, okay, these are the set of policies that need to be set up in the platform to be able to support the client's requirement of setting up this multi-org unit leave policies. So that's how the translation of raw, unfiltered client's requirement discussions get translated into a detailed technical requirements that can go directly into the configuration phase from there. And in the configuration phase, we take these BRD documents, any functional design documents, and any other context notes that you would like to add. And then the orchestration layer, as Bo has mentioned, is no more sitting just about suggesting what to do. It is actually doing the configuration. It is setting up your configurations, integrations, workflows, permissions, all the layers that you would actually set it up in the platform that you are setting up for the client. It is actually setting up those configurations. And once those things are set up, it would actually help you to be able to generate the test cases, and the BRD and the configuration that is set up would become the source of truth to generate these test cases, along with the knowledge graph, of course. And the output for that would be the test cases for this specific client and on fully tested configuration report, which is a UAT report that gets generated. So you would be able to minimize the back and forth between client and you, because you already know that everything that is set up is already taken care and the UAT report has been generated. So you all have experienced that whenever the testing is given to the client, once the configuration is set up, you then unearth a lot of new requirements and change requests. And this UAT report is going to help you clearly distinguish between what is covered and not working and what is a new requirement that is being now created as a change of scope. And this will expedite in reducing any back and forth that would happen between configuration, testing, and reconfiguration of the systems. And once you get a sign off on the UAT, the orchestration layer would then help with the data migration. So in the configuration, you are setting up the master data. In the data migration, you are setting up the historical and transactional data. So you are pulling a lot of records from either different tools or exports. Typically, you see two kinds of data migrations. One is tool to tool, and second one is data to tool. So in tool to tool, let's say you are transferring the data from Workday to ADP. It is transferring between two different systems. It's tool to tool. And when you're exporting the data from Workday as files and importing it into ADP, that's data to tool. So in both cases, the orchestration layer will be able to connect the systems together and do the field level data mapping. It can help you with convergent fields, divergent fields, data lineage mappings, transformation functions, data validations. All of that would go through in the data migration phase. And the output for that would be an agentic ETL layer that is seamlessly transferring millions of records between both the systems. And wherever there are failures, you will be able to see the exact possible reason for failures and can let the orchestration layer retry that specific record or all the failures at once as well. And with this, the majority of the implementation is done. And then you move to the final stages of cutover, where you would take the UAT sign-off and the data validations and move it to from lower environments to production, and also take care of a bunch of admin and operational nuances to be taken care to take it go live. So as you see, the orchestration layer could help in a much tighter transitions and handshakes between one stage to another, connecting the stakeholders across the departments without losing a single ounce of context, and making it much more tighter execution and much more auditable and governed execution as well. Today, your data is also spread across PSA tools and in people's minds. This would create a detailed audit log of every single execution both the AI is doing and the human is doing together, so that for a single project, you would generate a scope of work requirement line item, and the same requirement line item is now getting branched out as multiple tasks in Blueprint, and each of those tasks are actually getting configured and then tested. So if you take a single requirement line item, you will be able to check the entire audit trail of its translation from requirement to blueprint to configuration to testing, and you know as an overall project how much of it is fully completed to end-to-end life cycle and how much of it is breaking. That visibility will be much more clearer. So I think we are getting to a stage where the level 3 is going to be the next stages of the regular PSA or the project management you do from the AI execution management directly. And the last piece to this is the hypercare, which is in a way an extension to the configuration agents, where they can help with all kinds of user queries once the implementation has gone live, with autonomous L1 ticket resolution, because essentially it's the same knowledge graph of the product and the context of this particular project that is already being captured in the implementation is going to be used to answer these queries, be it L1 or L2 or L3 as well, where it can debug the workflows. Because if I'm able to create a workflow, I can obviously be able to fetch the same workflow data and figure out where the gaps are and help troubleshooting that as well. So this is how a fully AI native orchestration of the entire implementation lifecycle would look like. We are not reinventing the process. We are now reimagining the process end to end through AI orchestration across the lifecycle. And given that, one of the key aspects that we keep looking at in the lifecycle orchestration is the knowledge graph. So let me touch base on what exactly I mean by knowledge graph. So essentially, with this AI orchestration or the agents, what we are trying to do is we are trying to create a digital twin of your best subject matter experts of the implementation. So how do we do that? We first need to understand what the consultant's strengths are like. The consultant's strengths are in two parts. Number one, they have the process experience. They know how to set the process in place and be as efficient as they can. And second, they also have very in-depth subject matter expertise of the domain and the product or the platform that you have, right? So now the process is something that you can easily train AI on, because it's at the end, it's just a workflow. But the product knowledge has to be a living knowledge graph that is the only way for you to be able to assist these consultants to be able to help with all kinds of their end-to-end lifecycle execution tasks. And this knowledge graph has three levels to it. One is the global context. So the global context is essentially the entire platform's knowledge. Every single screen of the platform, what actions that can be done on the platform, and the server calls or the executions between the front end and the back end for those actions as well. So once this is captured as a global context, then you also have a subset of the global context called runtime context. So the difference between runtime context and the global context is global context is applied for every single project's execution, but runtime context is applied only for specific clients in specific geography or in specific domains or based on certain rules. So they are still global enough, but cannot be applied across all the clients. And then you get to the project context, which is that specific project or the client's SOPs, RFPs, the intake sessions, what exactly they need to be set up, their data, that becomes the project context. So any orchestration layer which does not have all of these three is still handicapped in one way or the other to orchestrate it end to end. If you are trying to create a note taker that can simply summarize your call recordings and trying to give generic tasks without having this knowledge graph backing it, it is still not able to perform the actions or the quality of output to your usual subject matter experts output quality, because you need both layers of context to be able to meet the subject matter experts quality and standardize that across all the team members across the implementation team, because not everyone in the implementation team are going to be your best expert. So this helps in institutionalizing your best experts knowledge across everyone in the team and make every single implementation as high quality standard as possible. And along with this, now we need to keep the feedback loop running. So this is what Bo was talking about in level 2, where you continue the feedback loop. If you can learn from implementations across projects, across subject matter experts, and loop it back into the global context. And this feedback loop will cover the workarounds, the limitations, callouts, hypercare learnings, everything as an execution memory, and then gets added back into the global context with an approval chain of your respective senior subject matter experts, so that you are essentially institutionalizing this entire knowledge without fragmenting this into tribal knowledge as it is today. And coming to the last piece of how we can make this work in a complex enterprise software environment is AI has evolved so rapidly that there are certain things that did not scale with it with the usual outcomes. So that's the reason we created a framework called GPT, which is governance, predictability, and transparency. So you should be able to govern the execution of these AI agents with the right human in the loop approvals and restricting it to the current access control that a human has without the need for a redundant security access control layer separately for agents again. And this also includes an capability for you to be able to control the usage, control the execution runs and the token consumptions as well. And then comes to predictability. It's been a hot topic across the AI ecosystem, where you see that a lot of these AI tools, the spend has been, or the cost has been a black box. And this is how at least we solve for it, where we always give the forecast of the tokens or the number of implementations that can be done, or what's the token consumption would look like across these implementations up front, so that you don't burn your pockets when you get into the actual executions. And it also gives you predictability to put it in your AOP budgets so that you know what you are getting into, what's the ROI like. And the last piece is transparency. Every single thing that the AI is doing should have an audit grade governance logs, which will give you the detailed execution logs and the traceability logs. And this entire thing is actually safeguarded by an execution harness to ensure that it is not going haywire in production executions. And this is possible only when you can clearly see, not just saying, okay, you utilize 75% of your uses. It should be able to tell you the exact tokens consumed for each of these executions and which projects are consuming more tokens and why is it so. Much more detailed transparency into the picture. So this is what we believe is the only way that enterprises can scale AI inside the ecosystems confidently without getting into it in a black box execution. And the last piece of this is I take it very seriously as a tech exec myself, is AI should not be treated as another multi-year transformation. It is not a regular tech wave where you have migrated from on-premises setups to cloud setups to Java to .NET to JavaScript. This is not a similar tech transformation wave that we are seeing. AI should work where you are. You should not be transforming your own architecture to let AI create an impact for you. This is something that I strongly believe as a tech person myself. And fortunately, at Beacon, we have created the layers in such a way that just with a demo account, we would be able to create a layer for you to let AI work on the existing architecture as it is. And this also means, as a great consequence, that the business teams who have been relying on the tech and product teams for a long time now to build workflows for them, to build automations for them, to execute logic for them, now business teams can take that control back in their own hands, because at the end, business teams are the ones that are deciding the logic. So now they get that control back to be able to execute that logic themselves. So this will help the PS teams to move past the dev sprints or product backlogs and control it on their own and move at their own pace. And this results in higher business impact instead of hiding behind transformation projects and lengthy transformation timelines across. And for this reason, the way that we execute this is you cannot commit to something in AI without seeing that working on your platform. And as a testament to the speed and as a testament to a no transformation motion, we do a 7-day POC, and we are happy to connect with any of the audience who are interested in doing that, where all we need is just a demo account, and we can build that knowledge graph, automate a chosen workflow of your choice or a module of your choice, and show you that Beacon automating the configuration part of it in 7 days and on your own platform. So once you see it in your own platform, you cannot unsee it, and that magic is something that will drive on its own into the internal business cases as it is. So this is what we believe the AI services engineering future is looking like. And I hate to say it is future because we already see the teams adopting it, and I think it's already present. And we believe there are much more innovative frameworks that are in store for PS teams. And it is time for PS teams to rise beyond the tech and create their own mark in the entire business lifecycle. So this would help in reducing your contracted ARR to ARR timelines. This would help in increasing your implementation throughput with the same team without scaling the headcount. There are so many qualitative outcomes associated with it, and I would love to hear Bo's thoughts on it as closing notes before we move to the Q&A.
Wow, Rakesh, I'm just really impressed with everything I've seen. I hope this webinar goes far and wide. Let me just leave you with a few thoughts, and I'd be interested in your reactions. And I think we have some questions that we want to get to as well. I'd say what you just saw is the whole argument made concrete. If you look at what threads through every stage of, I'm thinking of the life cycle graph, the knowledge graph. If you look at every stage of that life cycle, the knowledge graph, that is engineered delivery, not improvised projects. Every engagement feeds the graph makes the next one smarter. That is just, I'm just going to say it, that's the productized 80%. And it's the learning layer that I showed you earlier, and it's been made real. If you look at the left side of each stage too, Gong, Zoom, Salesforce, legacy files. And that's the disconnected data most of us are drowning in today from those platforms and a zillion others. I would say the power here is not necessarily just in the AI, it's that the AI finally has a place to stand. Your systems are not integrated. This does not work yet, right? If they are integrated, it's going to work. So I would say, I think it deserves a caution. I hear everything you just said, Rakesh, but I would add that this is the destination, what we're seeing here. And most of us aren't standing there yet because AI amplifies whatever process you pointed at, including a broken one. So maybe it's not wise to chase the whole picture on Monday. Pick a stage, engineer it properly, earn the next one. And the last mile is where the value has always lived. I think what's changed is now we have platforms like this one where you can finally engineer it. So anyway, I'm just blown away and impressed, and I was really super interested to hear everything, and would love to hear your thoughts, and maybe I think we have some pretty good questions that have been queued up as well.
Sure. Do we see the Q&A?
Yeah, I can jump in here, Rakesh. I'll just remind everybody, if you do have a question for either of our speakers, please go ahead and put that in the Q&A box, and we're going to get through just as many questions as we can with the time that we have left. And our first question here comes from Jerry, and they say, if the implementation knowledge is continuously changing, how does the system decide what knowledge is trustworthy enough to use for the next execution?
Yeah, I think it's a great question, Anissa. So I will just segregate the implementation knowledge into two categories. Again, I'm thinking it from the subject matter expert's shoes. As an SME myself, let's say if I have to think of the implementation knowledge that I have in my mind, it's generally of two categories. Number one is all the workarounds and the use case fitments knowledge that I have, and I'm gathering with every single implementation. That's an implementation knowledge. And second, the product knowledge, and as the product is evolving, the newest updates and the knowledge of all the new capabilities of the product. So on both sides, there is a reason why we were saying that as a living knowledge graph, because for the first category, where it is a runtime implementation knowledge that we are gathering with every single project executions. So this is generally how it works. Let's say I'm executing a project, and while executing the project, I have hit a different use case today, and I have solved for it. And while the AI orchestration is executing it, then I would say, okay, this is how you would do it in this specific case because it was not covered any time before. And now the AI now takes this as a cue and says, okay, do you want me to remember this for future as well? And I say yes, it would just go and sit in an approval bucket. And this approval bucket is reviewed by senior subject matter experts as a central COE, where they would see and realize, oh, so this is definitely a use case that we want everyone else in the team also to know. And the AI should start doing this going forward across all the implementations as well. And then approve this, or sometimes they can improvise that because they might be having a bigger picture and they might generalize that and be able to do it. And then it gets added to the knowledge graph. So that's how the living knowledge graph gets updated with every single execution of the project that the PS teams are doing. So this is category one. And category two, with respect to the product updates knowledge, again, with every new product release, let's say your UAT release of the product can be synced with the knowledge graph, and the knowledge graph will tell you what are the set of tools or actions that are different from the previous version, and you will be able to review that and run a regression, which will show you that, okay, you have done 100 implementations in the past, and if you run the same today, these are the ones that are going to break. So you would be able to see that regression results before it goes to production. And this is how you're building in harness layers to ensure that your implementation teams working in production are not impacted adversely by any product releases, and you are always up to date with it. So the regression and the sanity tests would help in catching up to the speed, and auto fixing the agents on top of it keeps you up to date with the product knowledge. So I think that's the way that with the human in the loop approvals, because I do not believe in autonomous understanding and execution yet. I don't think we are there yet, because this means that we cannot tamper with enterprise production instances with an autonomous learning, because it has to be a human in the loop approval, review, and execution, but AI doing the most of the heavy lifting for them. We can go to the next question, Vanessa.
Okay, our question comes from Raghu, and they say latency and token costs become significant when you're running AI continuously across large implementation workflows. How do you make AI execution economically viable at enterprise scale?
Yeah, indeed. I think this is what we were discussing in the GPT framework earlier. So there are two answers to this. Number one is AI process optimization. Second is the technical optimization. Again, given the tech affinity that I have, I will start with the second one. On the tech optimization, not every single task of the entire life cycle should be done by the topmost model. So you have model fusion, you have dynamic router allocations to help you with which model to execute for which kind of task, and when to escalate it to higher models as your execution is not solved by the lower end models. And the caching layers, the transformation layers, as you do more and more implementations, will get strengthened to bring down your cost cost of execution for implementation over a period of time. You are trying to look at much more stable graph than unpredictable ups and downs by following most of these technical optimizations. And these are only going to get better, because as the tech gets better, this is only going to get better. And on the process optimization side, again, you need to know which kind of agents to make part of it to be deterministic and part of it to be probabilistic. Like, for example, when you're executing test cases, you cannot expect the test cases to be fully running with LLM for every single run. Instead, the LLMs will run with respect to the first round of execution of those test cases at once based on the client's requirements, and the further runs will run in an automation, and the LLM will come into the picture only when there are failures, right? So that is how you would optimize with respect to the process layers as well. And by obviously creating a transparent layer of the cost utilization will help you keep the costs in check and brings in more confidence for the C-suite to be able to approve these kind of projects.
Now, I'd really like to just take this time to thank both Rakesh and Bo for delivering an outstanding session. And thank you to everyone for taking the time out of your busy schedules to join us for Services Engineering, from one-off projects to repeatable delivery. Brought to you by TSIA and sponsored by Beacon.li. We look forward to seeing you at our next TSIA webinar. Take care, everyone.